Hello everyone again and welcome to the Dajo Merit YouTube channel, and it's really great to be back again and talk to you about something quite interesting related to organic chemistry. And before we dive into this topic, please don't forget to hit the like, share and subscribe so that by way others can actually get a chance to check out this video, get inspired and also get great knowledge and succeed as one family. So let's dive into this by focusing on how these four compounds that I'm going to show to you all are quite similar in a way. They are natural occurring compounds, and what you notice is that seeing all this, we see that they share two things in there. First is that they have benzene rings, of course, and secondly, at least there is one hydroxyl group, which means that they are part of a specific family which has the hydroxyl group attached to the benzene group as highlighted right there. So in this case, if we have this hydroxyl attached to the benzene group as shown in this structure, this actually is known to be phenol, or also known as hydroxybenzene. Now, we don't usually go with hydroxybenzene because hydroxybenzene is quite long, but we go by the short form, which is phenol. And in this part, since you've seen the structure, which has the oxygen with two lone pairs and two bonding pairs, one bonding pair with the hydrogen and the other bonding pair to the benzene ring. In this case, we've seen the structure, but now looking into the nomenclature, this nomenclature will help us to identify various families within this particular phenol group, and also how the change in the specific attachment within the phenol group, mainly around the ring, will actually influence how naturally good or beneficial the compound are, or in that case, how detrimental it might be in some specific cases. So going in here, we're going to see the derivatives of phenols, and one is actually called naphthol, and naphthol is actually seen to have two benzene rings fused together with a hydroxyl group attached to carbon 1, but in this case it is attached to carbon 2 within this benzene ring. In carbon 1, if the hydroxyl is attached to carbon 1, it is known to be the alpha form of naphthenol. However, if you look at it on the other side, it's actually attached to carbon 2, which means that it is beta naphthenol. So going in this part, there is another type of phenol which is called phenanthol, and phenanthol has three benzene groups fused together with the hydroxyl group attached to one of the carbon, and in this case, by numbering, the hydroxyl is attached to carbon 9. In this case, it is called phenanthol in this part. So looking at the numbering, that gives it away, and once you're able to see the derivatives of the phenol, we're going to now dive into nomenclature, which is how to assign names to phenols. And in this case, once you identify the hydroxyl group importantly attached to the benzene group, we promise that that has to be the parent name of that particular compound. So in this case, we have three that we're going to touch on in terms of what you should watch out for, either on the test or in various examples in the textbook. One form is when you notice the presence of an ortho, meta, and para direction, where the primary function, which is in this case the phenol, which has hydroxyl and benzene, within the benzene ring we have another functional group attached to the 5 carbons, one of them. So in this case, the first one in here, by numbering, we notice that in this part we have the nitrile attached to, counting from number 1, which is a carbon attached to the hydroxyl, and then we move clockwise, that becomes carbon 2. And then from there, if you're naming that particular compound, it is actually called 2-nitrile phenol, because phenol is the parent compound and then the nitrile is the functional group attached to the parent compound. So in this part, since the functional group is attached to carbon 2, it means that it is ortho to the carbon 1, which is the carbon attached to the hydroxyl. So in this case, it is called orthonitrile phenol, or you just put O. The second part here is that the bromine is actually attached to carbon 3 relative to carbon 1, which has the hydroxyl in there. And so by numbering, which is attaching our functional group to the lowest assigned carbon number within that particular ring, this is actually called 3-bromophenol. And in this part, since it is attached to number 3, we actually call this to be meta, because the functional group is attached to carbon number 3 relative to the primary functional group, which is the phenol right there. And finally, we have chlorine, which is attached to carbon 4, counting clockwise because that is the least number. If we count counterclockwise, that is also still carbon number 4. And in this case, if it's carbon number 4 directed to the main particular functional group, it is actually also called para or P chlorophenol. So that's about it for the ortho meta para directing. Ortho is carbon 2 relative to the primary functional group. Meta means carbon number 3 directed or relative to the functional group. And para means carbon 4 relative to the primary functional group right there. So for this second step, which is another one that you might come across, we have a methyl group attached to a phenol. This is also called cursol, and cursols, they are pretty much similar with respect to the naming of the ortho meta para directing. And in here we have 3 examples. What we notice is that the methyl group is attached to carbon number 2. The next one here is the methyl group attached to carbon number 3. And then the last one is the methyl group attached to carbon number 4. There are 2 ways to answer this question. For the first one, this is carbon number 2, we can call it 2-methyl phenol, or you call it ortho cursol. That's the most important one. And next one is that the methyl group is attached to carbon number 3, we can call it 3-methyl phenol or meta cursol. And then finally, we have the methyl group attached to carbon number 4, in this case 4-methyl phenol, and or is called para cursol. So this leads to the final one, which has diols of benzene, and the diols means that in this case we have 2 hydroxyls attached to benzene ring. So in this case, we just use one of that particular hydroxyl as the main parent function or primary function, which is contributing to the name phenol, and then the other hydroxyl will be used as the substituent. Please take note that the parent name for this particular compound is benzene diol. So in this case, we have the first one, which is all these in here, and then you have your hydroxyl, which is attached to carbon number 2, which is 1,2-benzodiol or catechol. Next one is the hydroxyl attached to carbon number 3. In this case, this is called 1,3-benzodiol, or it is called rhinosdiol and rhizonol. That's kind of a complicated name. And then the final one in there is actually hydroxyl attached to carbon number 4. We actually go with 1,4-benzodiol, or you can go by the other name, which is hydroquinone. The ones in brackets, we don't really need to worry about those ones in the diol section, but the ones with the ortho meta para directing, which has the ortho meta para of the chloro, bromo, and nitro phenol, you do really need to take responsibility knowing those specific names. So that's about it for the nomenclature, and then finally we're going to look at great applications of phenols or hydroxybenzene. And one application is hormones, and we have so many hormones in our body, specifically sex hormones, which are all cholesterol linked. And if you look at this hormone specifically, we see these fused rings, but they are all having a specific group, which you notice the benzene attached to the hydroxyl, and in this case this actual hormone is called estradiol, and in this part this is actually the female sex hormone, and it's quite beneficial and important in various interesting biological processes in the female development. And the next one in here is called the antioxidants and antibiotics, and applications of this is actually crucial in terms of various important chemicals like tetracycline. And in here you see the four cyclic compounds, and you observe as well that the first ring, reading from left to right, actually has the benzene ring attached to the hydroxyl, or the hydroxyl attached to the benzene. In that segment we have the phenol right there, and then if you read from left to right, we notice that there is a specific Y group and we have a specific Z group, and in this case where our Y is actually chlorine or Z is actually hydrogen, in this case we can actually name this particular tetracycline to be called erythromycin. And the last one here is when Y is actually hydrogen and Z functional group is hydroxyl, because it's terramycin. So that's about it for antioxidants and antibiotics. This tetracycline is actually an antibiotic, and the diversity of antibiotics related to the tetracycline is really fascinating, and that is how beneficial this is in terms of the overall structure coming from phenols. And finally we have the blistering agents, and blistering agents can be found mainly in, what's the name of these guys again? Poison ivy. Yes, and in poison ivy we have this particular strand of agents which are called the uroshilols, and the uroshilols, they have this particular benzene ring attached to two hydroxyls, which is a form of a benzodiol in a way, and then we have an R group attached in here relating to which hydroxyl you actually pick. It actually has a long alkyl chain which is almost close to 15 carbons. So this is actually known to be found in poison ivy, and it could really be irritating in this particular part right there. But overall, really fascinating to see the applications of these particular phenol groups in nature. And we have other ones, like the one at the top, we have the thymol, which is also found in thyme. And in this other one right there, we have the methyl salicylate, and this is actually found in oils, mainly oil of, I would say, wintergreen also, which is quite interesting to find that the wintergreen. And finally we have the amino acid, which is tyrosine, and tyrosine is quite crucial in terms of biological processes and building of various proteins coming from this particular amino acid. So that is about it for this particular video. I hope you're able to understand the diverse look of phenols, and in future videos we're going to look at how phenols is important in various crucial chemical reactions and how we can actually introduce diversity to the phenols to give it its functionality either in a positive way or in a not so convenient way. So all the same, please don't forget to hit that like again, share, subscribe, but that way others can actually get the chance to check out these videos. And please hit the comment down below, let me hear your thoughts about anything that you may have struggled with, and we'll see you on the next part of these videos. All the same, stay smart and believe in yourselves.